Imagine the universe as a giant pool table, where the laws of physics are the rules of the game. Stars and planets, like perfectly aligned billiard balls, hurtle through the vast expanse of space, each following its own trajectory. When these celestial bodies collide, the results are spectacular. Supernovae erupt, galaxies merge, and the universe is constantly reshaped by these grand events. From the chaos, new stars are born, lighting up the cosmos with their brilliance. These cosmic collisions, while seemingly chaotic, follow a set of elegant rules, much like the game of billiards itself, where every move is calculated. In the world of physics, we call certain collisions elastic, where objects bounce off each other without losing energy. Just like a perfectly executed shot in billiards, elastic collisions are characterized by a fascinating property: the conservation of both momentum and kinetic energy, ensuring a seamless transfer of motion. But what does that mean exactly? How do these principles apply to the universe at large? Let's dive in and explore the enthralling realm of elastic collisions and uncover the secrets of these cosmic interactions. Imagine two billiard balls colliding. They click sharply, transferring energy between them. In an ideal scenario, no energy is lost to heat or sound. This is an elastic collision. In simpler terms, an elastic collision is like a perfect bounce. Think of a bouncy ball dropped from a height. It rebounds to almost the same height, losing very little energy in the process. Elastic collisions are fascinating because they reveal fundamental laws governing our universe. By understanding these collisions, we gain insights into everything from the motion of atoms to the behavior of galaxies. The magic of elastic collisions lies in the conservation of momentum and kinetic energy. These principles are fundamental in understanding how objects interact in a variety of physical systems. Momentum, simply put, is a measure of a moving object's tendency to stay in motion. It is a vector quantity, meaning it has both magnitude and direction. It's calculated by multiplying the object's mass by its velocity. This relationship helps us understand how different factors influence an object's motion. Kinetic energy, on the other hand, is the energy possessed by an object due to its motion. It depends on both the mass of the object and the square of its velocity. In an elastic collision, the total momentum of the system before the collision is equal to the total momentum after the collision. This means no momentum is lost in the process. Similarly, the total kinetic energy before the collision equals the total kinetic energy after the collision. This conservation is crucial for predicting the behavior of colliding objects. These concepts are represented mathematically by equations that allow us to predict and understand the outcomes of collisions. By applying these equations, we can solve complex problems in physics and engineering. The conservation of momentum and kinetic energy in elastic collisions is a testament to the elegant bookkeeping of the universe. These principles ensure that the universe operates in a predictable and orderly manner, where every action has a corresponding reaction. These quantities are never lost, they're simply transferred from one object to another. This transfer can be observed in everyday phenomena, from the simple act of playing pool to the complex interactions of celestial bodies. Think of it this way: the universe has a strict energy budget. Just like a well-managed financial account, energy is meticulously tracked and balanced. In elastic collisions, the total amount of momentum and kinetic energy remains constant. This constancy is a cornerstone of classical mechanics and helps us predict the outcomes of various physical interactions. It's like exchanging one currency for another. The total value remains the same. This analogy helps us grasp the concept of conservation in a tangible way. This principle of conservation is fundamental to our understanding of physics and governs countless phenomena in the universe. From the smallest particles to the largest galaxies, conservation laws are at play. Understanding these conservation laws allows us to make sense of the world around us, from the motion of atoms to the movement of planets. They provide a framework for interpreting the natural world. It's a powerful tool that helps us unlock the secrets of the cosmos. By studying these laws, we gain insights into the fundamental workings of the universe, revealing the intricate dance of energy and matter.